Alright guys, what is up? Welcome back to Minecraft with Lone Debater 7, and today I want to go over some basic memory circuitry. That way you can store the state of an input even when the input is off. So the reason why you'd maybe want to do this is if you remember our combination door that we built using levers, basically, you know, once you figured out a lever wasn't trapped, you could just leave it flipped and slowly work your way through to build a combo. Well, you can effectively use this guy here to store the input of a button, and then basically you pulse through in order to send it out. But let me kind of show you. So this is called a basic Rs Latch. So this is our output. I've got lamps so we can see, and this is the R. This is the R. This is the S. So S just means that's your input, R is for your reset, so that's the reset switch right here. And the way this works is if we trigger the input, we've got our output over here, right? Well, if we turn it off, it stays on until we flip the reset switch, and then it'll match the state that this is currently in. So if we're doing binary talk, 0 is when this is not pulled, 1 is when it is. So if we turn it to 1, and hit the reset switch like that, it's going to store that state for us as 1 until we flip the reset latch. Then it'll match the state again and you can start over. So when you trigger that, it's going to go through, light up the lamp, hit your reset switch, it'll turn it off. But you can turn that, so basically even though this is off, the input is off, the output's still on, and then you can reset it with this. So kind of the way you would use this to build a door is you would use buttons instead of levers. You'd have them push this and it will output the signal continuously, and then you would just have an extra button that resets all of them, so they have to start over with the code. Anyway, so that's the Rs latch. The next one here is called a D flip-flop switch. So basically the way this one works, this is your input, so that turns it on, that turns it off. But let's say we wanted it to stay on, we flip the switch to turn it on, and then we flip this guy right here, and when we turn it off, it will maintain the state of the output. Basically, this will allow you to store a single bit of info. If you turn it off, it loses its state and matches this. So turn it on, turn on the lock, turn it off, there you go. So same thing, you could use this as opposed to this to build your button layout. It just kind of depends on what's easiest for you. This one does take up significantly less space because it's only 2 repeaters in redstone, as opposed to blocks, torches, and redstone. Next, this is just a D gate, I apologize. So this is called a D gate, or a D switch rather, I apologize. And so there's the D switch. This is called the D flip-flop. So basically what this one does, you input here, right? And it's only going to update the output every time this clock cycles. So basically what you can do here is you can connect it to a little redstone clock like we showed last time, and every time the clock cycles through 2 of them, it will update the state of the output. So if we turn this off, it's going to stay on until the clock cycles. So if we leave that on and turn this on, it's not actually going to pass the signal through until we flip the clock through another cycle, and then it'll stay in that state until we flip the clock through. So that's D flip-flop. Kind of good if you want to control the update status of your outputs. So this is a little bit more complex than the guy next to it, because you have to add a block, a torch, and 2 extra repeaters, but it does give you a little bit more control on the duration of, you know, your output being the same. So it takes 2 flips, because basically the way this works, when you turn this on, it's going to go to this signal. Since this guy is powered, it will not input into this repeater, but once we flip it to the second one, it will go into that repeater. So let's just turn that off and kind of show you. So right now, it's as you switch the states, the one that doesn't have power on the repeater next to it will update its status. So as you can see, this is off, that flipped from on to off, and then when we flip it again, the next repeater in sequence will flip off. If we turn this on, while this one is on, it will not update this repeater. So that's how the D flip-flop switch works. Next, we've got a little bit more advanced version of it. Basically this one, you've got one input that turns it on and off, and every time the clock cycles twice, it will re-update the output. So this one can be good if you're trying to like smooth out the output of a clock, for example. You pass the clock input here, and only every so let's just say we started like this, so 1, 2. So it has to change states 2 times, so it goes from powered to unpowered to powered, or unpowered to powered to unpowered. And that's kind of how this guy works. Next, I've got this guy. It's basically a little bit different version of the Rs Latch. So we've got an OR gate here which controls your circuit. That's your reset switch, so that, well, it doesn't lock the state, but whatever. I may have built this one wrong, but yeah. Or no, I didn't. So when that is open, it's going to remember the state of your OR gate, and then if you want to update the state, you flip this one and it resets the circuit. So that's kind of how this guy works, same as the Rs Latch that we showed over there, just using a piston instead of torches. But yeah, so that's kind of your basic memory circuitry for Minecraft, more or less. You can do some pretty cool stuff, all things considered, but you know, you kind of have to figure out how you want to apply all the various pieces here in order to accomplish what you want. A great example is building a combo door. Like, you could use these D switches or the RS switch in order to make it utilize buttons instead of levers. That way, you know, you can't just crack the code by guessing. You actually have to know it. So we'll probably build a new combination door in this world utilizing either the D switch or the D flip-flop switch, whatever. And this one's called a T switch. So that's a T switch. Anyway, we'll probably build a new door just so you can kind of see how that works. Basically, what you would want to do, you'd have your input, right? You'd pass that through. And when you're ready to submit the combo, you flip your lock state lever, and that will ensure that it remains firing, right? Anyway, so we'll show that off once I actually build it, so you can see how you'd go about constructing it. But that is my coverage of the basic like memory switches or memory gates, whatever you want to call them, for Minecraft using Redstone. If you enjoyed the content, be sure to like, comment, subscribe as always, and until next time, this has been Lone Debater 7, and we will see ya.